Well, hi, everyone. My name is Soifer. I'm a PhD candidate in nutrition and hospitality management, and I will continue talking about non-parametric statistics. We have covered basic concepts and also Spearman's correlation. So I'm going to focus on Fisher's exact test and also will give you the opportunity to practice. So, as you know, if the data is interval or ratio and we have two independent samples, we're just going to do an independent t-test. But what if data are nominal and not normally distributed? And you may still want to test the relationship between the two variables. So you know that sometimes distributions of data are not normal. Data are best collected nominally or categorically. Or interval or ratio data needs to be collapsed into a small number of categories. So what do you do? In this circumstance, there are two options. You can do chi-square or Fisher's exact test. Again, just to give you the overview, right? So interval ratio data, what we usually deal with, like Likert scale, will give you two independent samples, and you will just run a t-test. Well, if it's a categorical or nominal data, you will run chi-square or Fisher's exact test, and I'll show you what's the difference. So the assumptions of those two tests are pretty similar. There are statistical methods to investigate statistical associations of two categorical or nominal variables. And three assumptions are the same. So first of all, data or sample is independent and randomly collected. The two variables are measured as categories. So the data in the cell should be frequencies or counts of cases or events. And the level or categories of the variables are mutually exclusive. Now, this is where the difference comes in. So for the chi-square, the expected values in each cell should be 5 or more in at least 80% of the cells, and no cell should have an expected of less than 1. This is different for Fisher's, and I'll explain how to find that out. So here's when you use Fisher's exact test, which we are talking about today. So we're going to later look at the relationship between sex and obesity. So we have two variables, sex, which is male and female, and obesity, obese or non-obese, right, with a sample size of 16. Again, I will demonstrate in SPSS that software calculates expected value, and if this expected value is less than 5, instead of chi-square, you would be using Fisher's. Or if expected value in a cell equals 0, you will use Fisher's as well. So let's look at this example. The research question is to investigate the relationship between the sex and obesity. So we have recruited 11 participants from Ole Miss, and we have two variables. We have men and women, and some of them are considered obese and some of them considered non-obese. So we wonder if there is a relationship between the sex and obesity. Again, following the 8 steps for hypothesis testing, step 1, we state the null and research hypothesis. So the null hypothesis is there is no relationship between sex and obesity. An alternative hypothesis is there is a relationship between sex and obesity. Step 2, set the level of significance regarding null hypothesis. And in applied science, we usually set our alpha level at 0.05. So we're going to do that here as well. Step 3, choose the appropriate statistical test. So we said that we have two categorical variables, men, women, and obese versus non-obese. All expected values, as you see later in SPSS, less than 5 Therefore, based on the table that I showed you earlier, Fisher's exact test is suitable. So again, how to check expected value? SPSS shows that to you. You go to Analyze, Descriptive Statistics, cross tabs. You select two variables, check cell and check expected. I'll demonstrate that, but right now, bear with me. So the output will look like that. And you see expected count. So if you have expected count less than 5 here in those cells, or 0, it means that you need to use Fisher's test. So step 4 in our 8 steps for hypothesis testing is compute the test statistics. And Fisher's exact test calculates the exact probability of the contingency table of observed cell frequencies under the assumption of that the marginal totals of the observed values are fixed. Now, thanks to statistical software, we don't need to calculate everything by hand, but we can if we need to. So this is the formula for calculating the Fisher's test. So you start with this p-value where n is sample size here, right? So we have 11. And then you have 2 by 2 tables. So you have A, B, C, and D. Easy to calculate A plus B and C plus D and plug it in to the formula. Now, these signs are factorials, which just means that you multiply the number by all integers smaller than the number. So like if you have, let's say C plus D is 6, right? So you're going to 6 multiply 5, multiply 4, multiply 3, multiply 2, multiply 1, and you will arrive to a number. So if you do that, you will arrive at P 0.065. Now, it's not the end of the calculation. You need to do that. You need to calculate probability for all possible contingency table with the same marginal totals. So basically, this red, so you see you have 0 obese men, 5 obese women, 1 obese man, 4 obese women, etc., etc. And so those in red, the ones that would go to your final P, and it is calculated by summing up all the probabilities less than equal to the probability of the observed contingency table. So in our case here, right, we got 0.065, 0.013, and 0.002. So, sorry, again, we sum it up. So your p-value, which you will see in SPSS, because obviously SPSS does these steps on the background. It doesn't show you that process. So the final p that you will see, p-value you will see, is going to be 0.08. Now, step 5 usually is determine degrees of freedom. We do not need to determine degree of freedom for Fisher's exact test. Determine critical value for rejections of null hypothesis. With the alpha level of 0.05, the critical value of P would be 0.05 as well. And then we need to make a statistical decision. So we calculated P and it's 0.08. It's larger than the critical value of P, which is 0.05. So we cannot reject null hypothesis. And as a result, we interpret the results that there was no significant relationship between sex and obesity, p-value of 0.08. Now let me run it in SPSS, and also I'm going to share. Sorry. I'm going to share that in chat. Okay, so I'm going to share my two files in chat. Bear with me for a second. So it's going to be practice 1 and practice 2. So practice 1, we're going to run. Oops, sorry. Everyone. Okay. So practice 1, we're going to run right now, and then practice 2, we're going to run later. Okay, everyone got it? You good? Okay, cool. All right, so let me start sharing that. And I'm going to Fisher practice 1. Everyone can see? Good? Okay. So nothing new here. Yeah, 11 participants. And if you look at the variables, men, women, obese, non-obese. You need to go to analyze. And I invite you to follow me. If you can open this file in SPSS and just, it's easier to remember when you're actually doing yourself as well. So analyze descriptive statistics, cross tabs. We move the variables here. And there are two tabs that we need to pay attention to. First is cells. Remember I said expected value, so it will show you, right? So you click on here again, cells, observed by definition and expected here, you click, and also statistics. So chi-square and phi and Kramer's V. Okay, we're all set. Now we just do okay. And let me show you the output. Okay, so the output here. First of all, we looked at the expected count, right? It's less than 5, everything is fine here. And then we looked at the results of Fisher's exact test. Remember those steps? Well, SPSS did it for us, but what we have as a result is that p-value here is 0.8. As we said that our alpha level was 0.5 and it is larger. Therefore, based on all that, let me go back. Again, just very quickly. So we're going to analyze descriptive statistics, cross tabs, move them here, those variables. You click on statistics and cells, observed, expected, chi-square, 5 and Kramer's V, click continue, and that's the output that we got. So, and this is your write-up. Your write-up is that 11 participants were observed to investigate the relationship between sex and obesity. Significance level was set at alpha level 0.05. Fisher's exact test indicated that the relationship between sex and obesity was not statistically significant, p-value of 0.008. Based on these results, it can be concluded that there is no significant relationship between sex and obesity. All right, everyone is with me? All right, well, this is essentially concludes the kind of theoretical part of the presentation, but I would love for us to practice as well. There is another file that I shared in the chat, which is quite interesting, I would say. So in this case, we recruited 13 participants, men and women, and we are wondering, is there a significant relationship between sex and preference of pickup trucks? So again, we have nominal variables, right? We have sex, which is men and women, and preference, yes or no. We ask them, do you prefer pickup trucks? They said yes or no. We have set the alpha level at 0.5, and we need to determine if a relationship exists between the two variables. So I invite you to try and let me know whether there is a significant relationship between sex and preference of pickup trucks. You follow the same steps. I'll give you 3 minutes until 12:45, and please type in the chat whether there is a significant relationship or not. In other words, do men prefer pickup trucks more than women do? All right, ready, set, go. 3 minutes to run this test in SPSS. Again, for those who are looking for a file, it's in the chat. Practice Fisher practice 2 file. So the question is there a significant relationship between sex and preference of pickup trucks? You can type yes or no, and the person who is the first will get the star statistician prize. All right, 12:45. Do you need more time, guys? Well, who would like to start? Is there a relationship or is there no relationship? Well, you can unmute yourself. Oh, okay. I think I'm missing a step after I get to cross tabs. Okay. Ethan, no relationship, right? That's what you're saying?
Yeah, there's no relationship between the sex and preference.
All right. So opposite to common sense. Because we always think that men prefer pickup trucks more. Our statistical results show that there is no relationship. And Chesney, let me just actually run it in SPSS, so you will get this step after you get to cross tabs. All right, we got our star statistician. Let's go run this test. Okay, my screen has just okay, we got our Fisher practice. Okay. Oh, okay, got for some reason got freezing a little bit. So we got here, perfect. All right, so we got 13 participants. Again, if you look at the variables, right, you got, again, men, women, yes and no. That was our question. Okay, so let's go. Analyze descriptive statistics crosstabs, right? That's the first step. So you click there. So now we have two variables and we need to put them rows and columns. And there are two tabs you should pay attention to. First is cells. So observed, already clicked, and expected. So click expected. So we actually see that the assumption of a Fisher test is met, right? Remember we said less than 5 expected count. And then statistics, chi-square and 5 and Kramer's V here. Okay. So now you said, let me just check for chat. Okay. Yeah, we're good. Okay. So, okay. And our output. All right. So our output shows here that, first of all, we did meet the assumption of Fisher's, right? And the line that you need to look at is Fisher's exact test because we're using it. And here is your p-value that you're looking at, right? So it's 0.1, 0. So 0.1, which is higher than our alpha level of 0.05 that we set for this test. It's higher. Therefore, let me just go back again. So as you see the results, right? They were not significant, right? It's higher than our alpha level. Therefore, we conclude that there is no significant association between sex and preference of pickup trucks. In other words, men prefer pickup trucks at the same level how female women do, right? So let's see. We got 13 participants were observed to investigate the relationship between sex and preference of pickup trucks. Significance level was set at alpha 0.05. Fisher's exact test indicated that the relationship between sex and preference of pickup trucks was not statistically significant. P-value is 0.1. Based on these results, it can be concluded that there is no significant relationship between sex and preference of pickup trucks. And this is your write-up for a manuscript. If you need to run Fisher's exact test, this is how you report your findings. All right, so that concludes my presentation. Do you guys have any questions?